So this is a circle and I have drawn three angles inside it. We have to find the unknown angles x and y. We'll use circle theorems to find all the unknown angles. So let us start with x. Now angle x is angle formed at the circle, at the circumference, which is inscribed in the arc AB. Similarly, there is another angle which is inscribed in this arc AB, and that angle is 35 degree formed on the circumference as well. The property says angles inscribed in the same segment are always equal, which means angle x is equal to angle 35 degrees. Secondly, to find y, now look at y, it is formed at the center and in the same arc AB. So if I look at y and if I look at this 35 angle, they both are inscribed in the arc AB. The only difference being one angle is formed at the center and the other formed on the circumference. Now the property says angle at the center is double the angle on the circumference in the same arc, which means this must be double this angle. Therefore, y has to be twice of 35 degree, which means y is 70 degrees. In the next question, we have a circle and we have a cyclic quadrilateral, meaning all four corners of that quadrilateral touch circle. So in such a quadrilateral, the property is opposite angles in a cyclic quadrilateral are supplementary. So opposite angles are x and 75. So they are supplementary, meaning when we add x and its opposite angle, which is 75 degree, they always add up to 180. Another pair in this quadrilateral which is supplementary is y, whose opposite angle is 85. So when we add y and 85, y and 85 when added must give 180 according to this property. Supplementary means their sum is 180. To find x, I transpose 75 to that side. It is 180 minus 75 degrees. X is 85 degrees. Sorry, 105 degrees. My bad. 105 degrees. Now next is to find y. We again transpose 85 to that side and we get 180 minus 85 is y, and when I subtract these two I get 95 degrees as the answer. So this is how we use cyclic quadrilateral property. In the third question, I have a triangle and a tangent. We are to find x, y, m, n, these four angles. I start with this triangle because in this triangle there is one angle which is known. Now this angle y is inscribed in a semicircle because this AC is a diameter passing through center O. So angle ABC is angle inscribed in a semicircle, so it must be 90 degrees. Angles inscribed in a semicircle are always 90 degrees. So when I use this property, I get angle y to be 90 degree. Now in this triangle, it is easy for me to find x because now I know two angles in this triangle. So I use angle sum of a triangle, which means when I add all three angles of a triangle, so x plus y plus 33 degree, the angle sum is always 180. Now I know my y is 90 from the previous part, so I substitute, I replace y with its value, which is 90, and I get sum 180. I solve for x, so x plus 123 is 180 Eventually, I get x is equal to 180 minus 123, which gives me x is equal to 57 degrees. So I know x, I know y. Now to find m, this angle M is formed between this tangent and chord BC. Now angle between a tangent and a chord is always equal to angle that is inscribed in this same arc, which is x. This theorem is called angles in alternate segments theorem. So M is equal to x, and x, as we have calculated, it is 57. Similarly, N, which is angle between this tangent and radius. So angle between tangent and radius is always 90. So we know n is 90 degree. We can also use this previous theorem which says angle between a tangent and a chord. Diameter is always a chord. So angle between a tangent and a chord, which is n, is equal to angle in the alternate segment, which is y. Y is formed in this chord, sorry, in this segment. N is also inscribed in this segment. So I get n equals to y equals to 90 degrees using this particular theorem. However, you can also write another reason for n, which says tangent is perpendicular to radius. This reason is only applicable to n, not to m. I hope these three examples are pretty clear and they are helpful for you to understand circle theorems. Thank you.